right, this is the second part of ellipses. Remember, an ellipse looks kind of like a circle that's smushed, right? An oval kind of shape. Your foci are inside. The A is the value from the center to the vertices. Your B is the value from the center to the co-vertices. And then your C value is center to the foci, yes? Major axis is the one with all the important stuff on it. That's what tells us if we're horizontal or vertical, and then the minor is the other one. So you might have had a question on WebAssign. I don't know if you guys had seen that yet, or if they asked for the eccentricity of an ellipse. It measures the ovalness of an ellipse, like how smushy to make it, pretty much. As that's obviously not a math term. But it kind of tells you how to draw it, what the graph looks like. How to find the eccentricity, if you're using a little formula, guys, you just take the C value and divide it by the A. So that might be something that you need on WebAssign, or if you're ever asked for the eccentricity. There's nothing crazy about that. It's just take the C and divide it by the A. Does that make sense? Okay. Just make sure you guys. All right, let's talk about finding the equations versus yesterday we had the equations and we found all the other stuff. First thing I think you should do is always give yourself a little picture. Kind of dissect what the information is that they're giving you. Give yourself some little notes, and then it kind of helps you direct which way you're going. First of all, what's important information here? What are you looking at? Where is my ellipse? Where is it centered? At 0, 0, okay? This makes life a little easier. So if you're going to draw yourself a little picture, I have my center here at 0, 0. Oh, okay. And then it says the foci. Foci. What value is foci? A, B, or C? C. All right. The foci is at 0, comma. It's at plus or minus 3. Okay. It's at 0, comma 3. And it's at 0, comma negative 3. You guys okay with that? You understand where those points are? 0, 3 is up 3, correct? And 0, negative 3 is down 3, correct? You guys agree? All right. So does anybody know what kind of an ellipse I'm talking about right now? Is this vertical or horizontal? Why do we know it's vertical already? Because the foci. Remember, the foci and the vertices are on your major axis. So I already know which formula to use. So I'm going to give myself an idea. I know I'm centered at 0, so I have x squared plus y squared equals 1. What value is going to go under the x? A or B? Why is it B? Correct. Because it's vertical. Remember, the bigger number goes underneath the major. So I need my A value and my B value. I have the C. So how do I find the value of my A or my B? Well, let's talk about this. What other information did they give us? Remember, B is the co-vertices, A is the vertex. What did they give me over here?
The major axis.
The major axis. Anybody remember what we said on that one slide about the major axis?
It's the one that the foci is.
Okay, it's the one that the foci is on. Good. It's the most important one. Anybody remember a little equation that it said? Look back. Okay, that c squared equals, okay, we're going to use that in a second. C squared. Why does my pen keep turning off? Okay, c squared, I agree. A squared minus b squared, okay. So we already know c, but what do I know? Go back to that chart, the first couple slides. What did it tell me about the major axis and the minor axis, lengthwise? Well, go back, look, actually scroll and look.
Oh, it's too late.
Yeah, it is. Major. The length of the major is 2 times A. If they told me the length of the minor, it would be 2 times what? B. Now, why is that important? Well, if they tell me how long the major axis is, so I could say 2A equals 8, so I divide both sides by 2, and what does A equal? A equals 4. So how far, guys, why is this important? Again, this is all problem solving. How far from the center is your vertex, your two vertices? Well, it's up 4, right? 1, 2, 3, 4. Here's one of them. And then it's down 4. 1, 2, 3, 4. Here's the other one. Everybody with? Okay, so now I know my A value is 4. I know my C value is what?
Negative plus or minus 3.
Okay, plus or minus 3.
We can plug them back into that.
What can I do?
We can plug what we know back into.
We can plug what we know back into. Angel just told us that C squared equals what? A squared minus B squared. So I'm going to go ahead and use that formula. I'm going to say C squared equals A squared minus B squared. Everybody agree?
How do you know whether to use the plus 3 or the minus 3?
Well, you're going to square it, so it doesn't matter.
Oh.
Good question. Hannah said, how do you know to use the plus 3 or the minus 3? Well, what happens when you square 3? 9. What happens when you square negative 3? 9. So there you go. All right, so I have 9 equals 16 minus B squared. Now what? Subtract 16? Okay. Negative 7 equals negative B squared. Before I take the square root, what should I do? Divide by negative 1. So I get B squared equals 7. So I take the what? So B equals plus minus root 7. Now, we have a lot of stuff all over the place. So I'm going to kind of organize over here. All right, I'm going to remind myself. I said that my formula was going to be x squared over B squared plus y squared over A squared equals 1. Do I now have my B value and my C value? Yes, and my A value, yes? Okay, so I'm going to write this as x squared over, well, my B value is the square root of 7. If I square that, what does that become? 7. Plus y squared over, what's my A value? 4. Well, what happens when I square 4? 16 equals 1. You are working backwards. Is this something that you guys can do one of and be like, I got it? No. You have to be methodical. You have to figure out, okay, what information are they giving me? What are they telling me about my ellipse? They're always going to give you enough information for you to figure out the pieces that are missing. All right? If all else fails, draw what? Draw a picture. Figure out what they give you just by plotting the points and drawing. All right, let's look at number 6. Again, center's at 0, 0. That means good. I got x squared plus y squared. So I know it's x squared plus y squared equals 1, and it's over something. I don't know which one where A is or B is. So let's talk about what they give us. The foci. Remember, that's what value? Your C. It's at 2, 0 and negative 2, 0, correct? You guys agree? Okay. And then vertices. What value is vertices? A. Good. My vertices are at 3, 0 and negative 3, 0. Some of you still don't see what kind of an ellipse we're talking about. Okay. Let's draw a picture. Let's draw a picture just so you can super duper duper for sure see. Here's my center. My foci, that's my C value, is going to be 2 to the right and 2 to the left. My vertices are going to be 3 to the right and 3 to the left. Where's all the important stuff? On the horizontal axis or the vertical? Horizontal. The horizontal. So I know the formula I'm going to use is x squared over A squared plus y squared over B squared. Correct? All right. So I need to know what A is. I need to know what B is. I need to know what C is. Do you need to know C? Do you need to write it down? No, but get in the habit of doing that. What are the two values we already know?
A and C.
Okay, what is A?
Negative.
Plus minus 3? Okay, and then what's C? Plus minus 2. Okay, again, when you plug this back into that C squared equals A squared minus B squared, like Hannah just asked, does it matter which one you use? No, because you're going to square it. But how would I find my B value now? I'm going to say C squared equals A squared minus B squared. So I have 2 squared equals 3 squared minus b squared. Everybody with me? What's 2 squared? 4 equals 9 minus b squared. Subtract 9 from both sides. Negative 5 equals negative b squared. Do you guys agree with me that b squared equals 5? And then take the, okay, so that your b value is plus minus square root 5. Now we figured all that stuff out, but we have not fully written the equation. Let's do that now. You have ax squared over a squared. What's your a value? 3. When I square it, it becomes 9. Plus y squared over b squared. When I take the square root of 5 and square it, it becomes what? 5, and then equals 1. There you go. Take the information that they give you and say, thank you. What do I do with this? Plot a graph. See if it's vertical, horizontal. See what values they gave you, and then work from there. How do we feel? Okay. Next one's a little, just trying to give you different different pictures of different things. Let's talk about what they gave us. It says the vertices are at where? Okay, so I have one vertex at 0, 5, and I have one vertex at 0, negative 5, correct? Okay, what value is that? A. A equals what? Okay, plus minus 5, so A is plus minus 5, so I know that A squared is how much? 25, okay. What do you guys know about vertices? Are they the important ones or the not so important ones? They're the important ones, right? So I have one at 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Now you're not asked to graph this guy. Yeah, it is. I don't know why I put that. In my mind, I wrote it differently. Sorry. Thanks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so now, why is this important? Well, we have discovered what our A value is. We have discovered which formula we're going to use. Where is A squared going to be under what letter?
Y.
Good. So go ahead, if you already know that, fill it out. You have x squared over b squared plus y squared over A squared is 25 equals 1. Some of you are going to want to work that way. Some of you want to work where you get everything first and then figure it out. Now, what do I do now? Okay. What else did they give me? They gave me something that it passes through. Is this a point? Yeah, it's a point. So let's think about what we know. If we have our original formula, x squared over, you said b squared, yes? Plus y squared over a squared equals 1. What do I already know in this formula?
Everything but b squared.
I know an x I can plug in, I know a y I can plug in, and I know an a I can plug in, correct? We're problem solving here. So now we're going to go back to algebra, and we're going to say, okay, well, instead of x, I'm going to put 4 squared over b squared plus, instead of y, I'm putting what? 2 squared over what? 25 equals 1. Everybody with me? Okay. So let's just simplify. 16 over b squared. My b's always turn into looking like 6s. I'm trying not to. Plus 4 over 25 equals 1. How do I solve this? Okay, so are you guys okay with me changing this to 25 over 25? Why did I do that? Common denominator, right? Okay, so I made 1. So now I'm going to subtract 4 over 25. And I get 16 over b squared equals what? 21 over 25. Now, a couple different ways we could do this. That's what I would do. Whenever I have a fraction equals to a fraction, the easiest thing to do is cross multiply. Some of you are going to want to say I multiply both sides by b squared, and then I'm going to divide. It's the same exact thing, but I would just go like this. I'd say, okay, I'm going to cross multiply here and here. What's 25 times 16? 400 equals 21 times b squared. You guys agree? Okay, so now I'm going to divide both sides by 21, and I get b squared equals 400 over 21. And then you guys are going to be like, and now we have to take the square root, and then we have to rationalize it. Do I really have to do all that? What goes in the formula, guys?
What does the second fraction say?
400 over 21 equals 21. It just says which fraction. Where are you looking? In blue or green?
Yeah, green.
It was an equation that just said 400 equals 21 b squared, and then I divided both sides by 21.
Oh, okay.
How come it is not important for me right now to take the square root? We want to work smarter, not harder. Think about what you need in order to write your equation. What are the two denominators you need? B squared and a squared. Do you already have b squared, guys? Don't make your life any harder. Let's go ahead now and write our equation. You have x squared over, what's our b squared? 400 over 21, okay, plus y squared over what? 25 equals 1, okay. Do I love the way that looks? No. So now you guys are like, oh my gosh, now what do we do? Guys, think about this. All right, we're back in algebra. X squared over 400 divided by 21 over 1, right? So we just keep change, flip. So what happens? Yep, you have 21x squared over 400. I would like you to simplify it to that. If you don't, if you left it there, I'm sure a point or two off, but I don't think it's that major of a deal. If you get to this point, a majority of your work was done there.
Wait, how do you do it now?
That's probably the hardest kind of problem you'll have to do. Was that hard because it was the kind of pre-calc conic stuff? Or was it hard because you had a fraction that we had to deal with? And as soon as we see fractions, we're like, oh, no, thank you. Yeah, I know. I hear you. All right, I'm going to change this problem here. Change that word minor to major. Number 8, change. Oh, wait, I'm on the wrong problem. I'm sorry. Wait, what does yours already say? Oh, it's already been fixed. My bad. I just looked down. I'm like, wait a second. Yeah, nothing. Forget what I just said. On mine, it said major, and I crossed out minor on the top, but I didn't actually realize what I was paying. Never mind. My bad. This one's already fixed. For what I did. No biggie. All right, here we go. You guys ready? All right. What do we have? What are we looking at? Where are we going? What do I do? My vertices are at 3, 3, and 3, negative 3. Okay, remember, vertices goes with what value? A, B, or C? A. Okay. Am I centered at 0? No. Do you know that right off the bat? Some of you are like, how did you know that? Well, when all else fails, guys, what should you do? Graph it. Draw a picture. If I go over 3, 1, 2, 3, and up 3, 1, 2, 3, I have a vertex there. And then I go over 3, 1, 2, 3, and down 3, I have a vertex here. So we've moved away from the origin. Do you see that? Okay, that's good that you guys noticed that. What kind of an ellipse do I have here? It's a vertical one, right? If I was going to draw a line right through all the important stuff, it'd be right there. So this is a vertical. Why is that important for us to note? Where does your A go? Underneath, underneath what? The Y, right? Your A value is going to go underneath the Y because the vertices and the foci are on the major axis, the one that's important. So I know my vertices are along the y. So I can say, all right, I'm going to use this. Well, we already know it's not at the center, right? So it's really x minus what? H squared, and then y minus k squared. What letters are going underneath? A squared's going where? Underneath the y, okay. And then my b squared's here. Okay, so what do we need? What do we need? What do we need? What do we need? How do I figure out my a value?
We know.
How do we know it?
Because it's the y of the
It's the y of 1 and the y, and the difference here, right? How far is it from positive 3, guys, to negative 3? 6 spaces, right? So where is the center? It's at 3, 0. How did we just figure that out, guys? Your center is at 3, 0. Why? Say that word again. Equidistant. How far are the vertices from each other? They are equidistant. I knew it was the change in y because this is a vertical. It's obviously not going to be 0, so that's good. Very good thinking, guys. So we already know our h and our k. Can we figure out our a value here? How far is the center from one of the vertices? How far is your center? It's 3 up or what? 3 down, so it's plus minus 3, right? Can you see the yellow? Not really. Plus minus 3, okay. What other information can we figure out? How?
Dividing the minor axis by 2.
Very good. I was wondering if anybody saw that. I know you guys were looking like, okay, do I know anything about the foci? Did they tell me anything? No, but what did they tell me? My minor axis length. Guys, what do you know about the minor axis? It's what?
where the co-vertices.
It's the co-vertices, good. And that little equation that was on one of the first pages was 2b equals 2, your minor axis. 2b equals your minor axis, 2a equals your major. So I can divide both sides by 2, and I find my b value to be what? 1. Can we now write our equation? Did we need to use the c value? Did we use the c value? Did we figure anything out with c? No, we didn't need to. But again, you guys are going to have to get used to problem solving here. So my center, remind yourself, this is your h, this is your k if you need to. So it's x minus what? 3. What's our h? So x minus 3 squared over b squared. What's b squared? 1. Plus y minus k. Do I need to put y minus 0? No. Could I put y minus 0 if you wanted to? Yes. I'm just going to leave it as y squared over, what's my a value? My a value is 3, so when I square it, it becomes 9 equals 1. Good job. Abigail, good job. 2 more.
Why did that other one stay as y squared?
Because your center is at 3, 0.
Oh,
Wait, so your co-vertices would be 2 and 4, right?
Yes. All right, last two. Last two. This should read 4, 0. All right. Now we're getting used to some things. So this is good. I see right away. I know what value, A, B, or C. Why do we know C? Foci. What is the value of? Well, we can talk about that in a second. You don't have to just say it right off the bat. What else do I know? Okay. I have my major axis. When I see the word major, I say, oh, that's 2 times A is 8. So what is my A value? What's my A value? 4. All right, so let's think about this for a second. Let's draw a picture. If we're not 100% sure, let's draw a picture. I have foci at 0, and then at 1, 2, 3, 4, 0. You guys would agree?
So it's 4 then.
Where would you guys go from here?
I would do the equidistant thing, and the center is 2, 0.
Okay, I would do the equidistant thing. I like that. Do you guys see what Abigail just said?
Yeah.
The equidistant thing? Because our center, you're 100% right. That's great. Where is my center then? It's in between these two, so it's right here. So you guys agree that the center is at what? 2, 0. Okay, that's great information. What else did we just discover by doing, I'm not teasing with you. I think it's really cute what you said. What else did we just discover by knowing the equidistant thing?
It's not at 0.
Okay, it's not at 0. Good. I know my A value is 4.
C is plus or minus 2.
C is plus or minus 2. Why is C plus or minus 2? What is the foci? It's the distance from the center, right? Center, that's your C. Center to foci is your C value. So if I know A and I know C, what can I figure out? Okay, so C squared equals what? What's the formula? C squared equals A squared minus B squared. Good. So 2 squared is, well, I'll write it out. You guys with me? 2 squared is 4. 4 squared is 16 minus B squared. Negative 12 equals negative B squared. So B squared equals what? Plus or minus the square root of 12. You could say 4 root 3. But do I really need to take the square root, guys? Leave it as what? Why should I leave it as B squared? Because that's what you need in the formula. You need A squared and you need B squared. We also need the center. All right, so I have my center, I have my A squared, I have my B squared. Do you guys agree with me that A squared is 16? All right, now I need to figure out where 16 is going. Is it going underneath the X or is it going underneath the Y? Why? You're correct, Coven. Why? Why though?
Because the foci are on the...
What's on the x-axis? The foci and the vertices, right? The major stuff, the important stuff. So we're going to write our equation. We're going to use this equation. X minus h squared over what? Over a squared. Good. Yeah, you're right. I just want to write out the formula. So let's plug in what we know. It's going to say x minus what? 2 over 16 plus. Could you say y minus 0, guys? Yes, if you wanted to, that's fine. You would not be marked off for that, but you don't have to. This is all about problem solving, taking your time, looking at the information they give you and saying, okay, what can I do with this? This next problem is pretty much the same thing. Now that we've done a few of these, when it tells you the major and minor axis length, it kind of makes your life a little easier. Again, if you want to have a picture, draw one. I think it's a good idea. Remind yourself the foci and the vertices are on the major, right? That's important information when you say, okay, I have something here and I have it where else? Up here, right? The major stuff would be your foci and your vertices. Where is the major stuff on this little picture I drew? On the vertical axis or the horizontal? Vertical. So that means when you're writing your x minus h squared over b squared plus y minus k squared over a squared equals 1. Why did I put a underneath the y? Because this is what kind of an ellipse? It's vertical. Think about what you just found.
The center?
What is the center, Miss Hannah?
0, 4.
The center is at 0, 4. I agree. Because the center is in the middle of the foci, correct? Good. So your center is at 0, 4. Perfect. And what else do I need to to write my equation? I need a squared and I need b squared. Do I already have a squared kind of given to me? Yep. How would I figure it out? 2a equals 16. They told us that our major axis length is 16. So what is your a value? 8. So what is a squared? 64. Good. Good, good, good. What is my c value?
4.
Good. So c squared is? Right? So c squared equals 16. Well, how am I going to find what b squared is, guys? C squared equals a squared minus b squared. You guys are so smart. So 16 equals what? Tell me. 64 minus b squared. We're going to subtract 64 from both sides, yeah? What's 16 minus 64?
Negative. Oh, negative 54. Wait, is it negative 40? Negative 42.
Or 48. We're close. We're close. We're getting there. We're getting there. It's that adding and subtracting that are getting us. So what does b squared equal, guys? 48. So let's go. Write this, then we're done. Write this equation. This is my h. If you need to remind yourself, there's h and k. Don't forget what variable is going underneath what. What does my equation look like of this ellipse? X minus, you could say 0 squared, that's fine. Over what? 48, great. Plus y minus 4 squared over 64 equals 1. How you'll probably see it written would be x squared over 48 plus y minus 4 squared over 64 equals 1. Good. Good, good, good. Is this super fun? No, I know it's not. It's okay. Hey, guess what we're doing next week? We're doing this exact same equation, but there's going to be a minus sign there. And what that does is instead of it being an ellipse, like, a little ovally kind of thing like that, your hyperbola looks like this. Boop, boop. It's like two parabolas. What it does is it's like your ellipse is cut in half and then flipped.
Equation's the opposite.
Just a little bit different, but you guys will be fine.